Hello everyone. Today let us see something about the internal structure of index set block. So if you have a fixed order B tree, then the previous method whatever we have done, the construction, that is easy. But if you have a variable order B tree, how can we construct, how can we set the index, and how can we build the B plus tree? So that is what we are going to study here. So this is a variable. I'm taking a variable length separators here and its corresponding index over here. So here you can see the different separators. You will be having a set of blocks, and inside the blocks you will be having a set of records, and using that blocks, using the last record and first record, we have chosen the set of separators now. So these are those separators whichever we have chosen. Okay, so neglect all the other things, we have only taken the separators, and here you can see the corresponding index for the separator. How we have written this index? So if you consider here, it is the separator AS. So here I have mentioned all the different separators AS, BA, BRO, C, etc. So the first separator is AS. So what I am going to do is I will take the index 0 0 before AS, right? So before AS 0 0 will be there, and next after AS you have utilized the two characters. So I am writing 0 2, 0 0 plus two characters 0 2. So next separator is BA, which is having two characters. So you are going to add 2 to this particular 2. So you will get 4 now. 2 plus 2 is 4. Next separator is BRO, that is having 3 characters. So you are going to add that 3 to this particular index. So 4 plus 3, you will get 7. So next index is 7. Like that you are going to write all the different indices. This is how you are going to write the index for variable length separator. Why this? Because you will be having variable length separator. In the previous one, separator length was assumed as it is fixed. So what we are going to do, if you have if you have separators, number of index is 3, in that is order of B plus 3 is 3, then you can have maximum 2 separators, that is fixed, right? But here if suppose it is a variable length, then this is the way how you are going to select the indices. So I can represent it like this: structure of an index set block. How can we represent it? So if you consider here, you can see all the separators. I have listed it out, and these are the indices whichever we have done here. The same thing I have written here, index to the separator. And now I'm going to write the relative block number also. Relative block number is nothing but when you have a separator, we are going to store it in we have the blocks for records, storing the record. So for each records or a set of records, we will be having blocks. So this particular thing represent that relative block number, or we call it as RBN. Okay, and here you are going to mention how many number of separators you have, total count of separator, and here you need to mention the total length of the separators. That is, we start from character A till E, how many number of characters are there, that we are going to write over here. 28 characters are there, that I am going to write over here. So this is how we are going to represent the structure of an index set block. I can show it simply like this. So here you can see, in this particular thing you can see B00 is nothing but RBN of that particular block, and AS is the separator. Once again B01 is the RBN, BA is the separator, B02 is the RBN. RBN is relative block number, and BRO is the separator. Like this you are going to write the blocks and separators if it is a variable length record. Now these are nothing but the separator subscriptors. We simply start from 0 till n minus 1. So next we'll see how we can load a simple prefix b plus 3. Now suppose if you consider this particular sequence set, you can see here the block 1, which carries the first record having key axis and last record is having key also. So in between there might be some other records also. We are going to consider only the first and last key. In the same way, second, third and fourth block we have there are 4 different blocks. Now if it is a variable length, then how we can set the next previous level, the next level. So in the next level what will happen, you are going to write the separators and its particular indices. Fine. So say my order of the tree is say 4, so I can have only 3 different indices in this, right? So if you consider this sequence set, you have 4 blocks, so there will be 3 separators, 3 indices, right? So I can have 3 separators like this. ALW, that is the first separator. How I got it? I got it from these 2 blocks, right? These 2 blocks, the last record of first block is having a also, so AL is there, and in the second block first record carries always, so AL is common in both. So I cannot consider AL now, I can consider ALW as the separator. So ALW is the first separator. So if I consider the index for this, I can start from 0, right? So 0 0 is the first index, I can write it as it is. So next comes ASP. ASP is the separator between second and third block, right? So ASP comes as the next particular separator. So what is the next index I need to write? I need to write 0 plus 3 characters, that is nothing but 03. I can write it as 03. So next separator is aspect best, that is the third block you have, and better and cast, that is having the fourth block. So the separator between these 2 blocks are nothing but BET, right? So I can take that separator over here, BET, and how can I add that? Already we have the index as 3, you need to add 3 more characters, BET 3 characters to this index, so you will get 6 as the index, next index. So this is how you are going to write, the next level of the tree. Now suppose you have one more block, say you have a block which is having the keys as catch and check. So next separator what I can write? I can take the next separator as cat, right? CA is common in both blocks, so CAT I can take. So cat is the next separator. So now if you want to add this to your sequence set, so what will happen? There occurs overflow in the next level. Why? Because I told order of the tree, say let us take it as 4, so you can store maximum of 3 separators in the in one node, right? So if I have one more block now, I cannot add directly to the previous level, right? So what I can do now, I have to create a separate block for this. But how can I create a separate block for this? Let us see. Say I have added this to the previous sequence set. Now if you consider this, now what I am going to do is I cannot write cat over here. Over here I cannot write cat. Why? Because I need to have one root, one single root. So if I write cat over here, how can I write the root over here? We cannot write any root, right? If you have two nodes in one level, it should have one node in as a root node. So that is why what I am going to do is I will connect it to a blank node. I am not going to specify anything over here. I will write a blank node with the -1 as the indicators. Okay, index block containing no separators. Then where I need to include the separator, I will include the separator over here, cat, with the index 0. Only one separator is there, so rest everything I have made it as -1, right? And if you consider now, if your key is greater than cat, then it will go to the last block. If your key is less than cat, it will come to this part and it will check the indices, and for the particular block it will assign. So this is how you are going to construct a B plus tree using this. If you have variable and separators, this is how you are going to so let us consider B plus tree, actual B plus tree. In the previous slides, we had seen simple prefix B plus tree. That means if you have separators, we are going to use that separators in the index set blocks, right? So here what we are going to do is, that is simple prefix. Prefix in the sense only some characters of the key we are going to consider, prefix we are going to take, and we are going to frame the separator. But here in the actual B plus tree, what happens is, if you have these two blocks, if you consider also and always, right? So in the simple prefix B plus tree, we had taken ALW as a separator, but here what we have done, we have taken the complete key ALWAYS, always, that key as a separator. And if you consider second and third block, ask and aspect are the keys, and aspect, we in the simple prefix B plus tree we had taken ASP as the separator, but here we are going to take aspect completely as the separator. So usually after B tree they have formed B plus tree, but in order to make it simple, once again they have made simple prefix B plus tree. So rest everything is same, all the steps are same. The creation of indices, how we have done, initially for the first, always for the first key we have 00 as the index. Next, always is having 6 characters, so 00 plus 6, you got 6 as the next index. And once again, if you consider aspect, that is having 6 characters, so next index I can write it as 12. 6 plus 6, that is 12. This is how, that is same for the both simple prefix B plus tree as well as B plus tree, but only the difference is, instead of the small prefix, we are going to consider the complete key as the separator in B plus tree. So I hope you all the things are clear for you.